discrete time sinusoidal sequences for several different frequencies. Sinusoidal sequence, all are sinusoidal sequences in discrete time for several different frequencies. For example, discrete time sinusoidal sequences several different frequencies. This frequency x of n equal to cos of uh, cos of 0n, that is equal to 1. So here all are 1, x of n equal to 1. 0 cos 0 equal to 1. So all are in this height 1. So here x of n equal to cos of pi by n, sorry, pi n divided by 8. X of n equal to cos pi n divided by 8. That means here signal here turn down in positive, then 0, then side, negative side, negative side, increasing, then step by step decreasing, same sinusoidal wave. Okay, so here cos pi n divided by 8. Divided by 8 means 1, 2, 3, 4, 5, 6, 7, 8. Yeah, then here start 1, 2, 3, 4, 5, 6, 7, 8. Then here start 1, 2, 3, 4, 5, 6, 7, 8. That's why divided by n. Pi n only divided by 8. Pi n n multiplication. Here these all are different frequencies. Here in C, figure C, pi n equal to cos of pi n divided by 4. It means sinusoidal signal only. Sinusoidal signal only. Okay. Here also sinusoidal signal. Okay. Here 1, 2, 3, 4. Here 1, 2, 3, 4. So x of n equal to cos of pi n divided by 4 in this frequency. Here 1, here pi n, that means cos of 0 n equal to 1. Here multiply, that is n multiplication with the 0. Here n multiply with the in cos itself. Here cos n multiply with the pi, then divide by 8. Like this. Then divide by 4. Pi n divided by 4 cos pi n divided by 4. Here divide by 8. Here divide by 4. Here divided by 2. X of n equal to cos of pi n divided by 2. So here 1, 2, then 1, 2. This is negative side. This is positive side. So 0, then minus 1, then 0, then plus 1. Here, for example, 1, 1, 2, 3, 4, 5, 6, 7, 8. It means 0, 1, 2, 3, 4. 4 is the maximum. So minus 3, minus 2, decaying, minus 2, 0. 3, 2, 1, minus 1, 0. Then like this. Here 0 minus 1, then 0 plus 1, 0 minus 1. In this, x of n equal to cos of pi n divided by 2. Here in figure E, x of n equal to cos pi n. Here, what is happening? Cos pi n. Here not any divide to pi n. Here divided by 2, here divided by 4, here divided by 8. All are pi n multiplication. Here 0, n multiplied with 0, n multiplied with pi. Pi n multiplied and divided by 8. Pi n multiplication divided by 4 in cos. And all are cos only. So here pi n multiplied and divided by 2 in cos. Okay. Fine. Then here in pi n only. So 1 minus 1, 1 minus 1, plus 1 minus 1, plus 1 minus 1, and go on. So on. Here 2 pi, only pi finished, 1 pi finished. Now 3 pi added. 3 pi, 3 by divided n. This is here only 1 pi n. So x of n equal to cos of 3 pi n divided by 2. So 1, that is 0 minus 1, 0 plus 1, 0 minus 1. Here happening. What is the in between? X of n equal to cos of pi n divided by 2. X of n equal to cos of 3 pi n divided by 2. Here that is 1, 2, that is 0 minus 1, 0 plus 1. Here 0 minus 1, 0 plus 1, 0 minus 1. So almost the same. Am I correct now? Here 0 minus 1, 0 minus 1, 0 plus 1, 0 plus 1. Like this. So almost same. X of n equal to cos of 3 pi n divided by 2 and x of n equal to cos of pi n divided by 2, almost same. Okay. Here x of n equal to cos of 7 pi n divided by 4. Cos of 7 pi n divided by 4. It means here divided by 4. So no need for 1, 2, 3, 4 in negative side. Positive side 1, 2, 3, 4. Okay. So what is the difference? Divided by 4. X of n equal to cos of pi n divided by 4. X of n equal to cos of 7 by n divided by 4. What is the difference? Yeah, it's 4 division. Okay. Any 1, 2, 3, 4. Then 0. Then 0. Here also 0. So almost the same. So cos of that is x of n equal to cos of pi n divided by 4 equal to x of n equal to cos of 7 pi n 4, almost same. Here x of n equal to cos of 15 pi n divided by 8. Where is the another 8? Here x of n equal to cos of pi n divided by 8. So divided by 8. 1, 2, 3, 4, 5, 6, 7, 8. Then this negative side. Positive side 0, from 0 start to 1, 0. 1 only starting at 0 itself. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then 1. So from 0 you will start 0, 1, 2, 3, 4, 5, 6, 7. 0 started. No? So almost same. X of n equal to cos of pi n divided by 8 equal to x of n equal to cos of 50 pi n divided by 8. Same. Here x of n equal to cos 2 pi n. X of n equal to cos 2 pi n. Here cos, here what is the difference between here and here? Here x of n equal to cos pi n. Here only 1 pi n, 1 plus 1 minus 1 plus 1 minus 1. Here 2 pi n all are equal. Same. So x of n equal to cos of 0 n equal to 1 is almost same with like x of n equal to cos 2 pi n. Discrete-time sinusoidal sequences for several different frequencies. Once again we will see here. The fact that first of these properties is different in discrete time is a direct consequence of another extremely important distinction between discrete time and continuous complex exponential. Specifically, consider the discrete time complex exponential with the frequency omega naught plus 2 pi, omega naught to 2 pi. E power j of omega naught plus 2 pi of n equal to e power j 2 pi n e power j omega naught n equal to e power j omega naught n. This is 1.5 one equation. From equation we see in this equation 1.51 we see that the exponential frequency omega naught 2 pi is same as that at frequency omega naught. Here also frequency same, here also that is in omega naught 2 plus 2 pi also same, omega naught also same. Thus we have a very different situation from the continuous time case, in which continuous time case is different situation, which is signal e power j omega t all are distinct values of omega naught. In discrete time, not like that. These signals are not distinct. As the signal with the frequency omega naught is identical to the signals with the frequencies omega naught plus 2 pi plus or minus 2 pi, omega naught plus or minus 4 pi, and so on, like this going on. So and therefore in considering discrete time complex exponentials, we need only consider frequency interval of length 2 pi in which to choose omega naught. Although according to equation 1.51, any interval of length 2 pi will do. On most occasions we will use the interval 0 to that is omega naught in between 0 to 2 pi, that is 0 is less than omega naught, omega naught is less than 2 pi, or the interval the omega naught is in between minus pi to plus pi, that is minus pi is less than or equal to omega naught is less than to pi, because of the periodicity implied by equation 1.4. The signal e power j omega naught n does not have a continually increasing rate of oscillation as omega naught increased in magnitude. That is,